We're going to be reviewing it pretty quickly today. So when you look at your notes that you should have printed up or copied out, I'm going to first talk about how to find the roots of a quadratic. So I give you a quadratic that looks like this in your notes. And these 2 points where it crosses the x-intercept, they're called the roots, the zeros, the solutions, and the x-intercepts. It's 4 words to mean the exact same thing. And all you have to do is pretty much figure out where it crosses the x-axis, no matter what it's asking you. 2 steps that I give you, you can either factor something, or if it's too in-depth to factor, you can use a quadratic equation. Now, in your notes, I have the notes right here. That's why I keep looking down. Sorry if it's kind of weird. This whole thing's weird anyways. I mean, the whole recording lessons and doing everything is, I'm still trying to get used to it. So, standard form of a quadratic. I give you the standard form of a quadratic. The main thing to remember, and I'm sure you guys do, is your A is your shape. And if it's a positive number, it means your quadratic is opening upward. If it's a negative number, it means your quadratic is going downward. And the other thing in standard form is your C, which is your y-intercept. You can also find your y-intercept by just plugging in, substituting a 0 for the x and getting your C all by itself. Anyways, going over factoring now. This is just a really quick review over factoring. And I give you a couple example questions. One of the questions that I give it to you in standard form. I say x squared minus what? 8x plus 12. And I have you factor this, and this is just review 2 numbers. When your A is equal to 1, you can find 2 numbers that multiply together to get 12, add together to get negative 8. So it would be x minus 6 times x minus 2. And then your roots or your solutions, your x-intercepts are 6 and 2. I also give you a difference of squares. Once again, these are just really simple equations. You guys can kind of put the pieces together if they're more in depth. And I give you a difference of squares. I say x squared minus 36. When you factor it, you're taking the square root of both of the terms, which is the square root of x squared is x. The square root of 36 is 6. One's a plus, one's a minus. This is review from last year. When you're solving, your answer is positive and negative 6, 0. That means your roots, or the solutions, it crosses at 6 and negative 6 on the x-intercept. Next thing is, when there's no real pattern, you can always factor out a term. And I give you an example question of, 2x squared minus 36x. And I say, the directions will be like find the roots. It's not going to be that easy, but they'll be incorporated in the question. So if you have 2x squared minus 36x, you can pull out an x from both of these terms, you can pull out a 2 from both of those terms and an x to give you, x minus 18. And then if you use a zero product property, which is the next thing where I say set everything equal to 0 when you're solving. If you set 2x equal to 0 and x minus 18 equal to 0, all of you guys are in STEM, so you should probably be able to figure out that your solution, this is going to be the origin if you're solving for your x, and this is going to be 18 because if you add 18 and move it over. And the last thing I give you is 3x squared minus 4x minus 4. And I'm giving you a question like this because it doesn't really have a pattern. Main thing to understand, your A does not equal 1, it equals 3. So most people, I think it's easier, let's say 3x squared minus x plus 4. Most people think it's easier when your A does not equal 1 and you can't factor out that 3 to use a quadratic equation. When you're using a quadratic equation, all you're doing is x equals negative b, which is a negative 1, plus and minus the square root of, you should remember this, b squared minus 4 times 3 times 4, all divided by 2 times 3. I'm not going to go over this, but this is going to give you, most of the time it's going to give you two solutions. Most of the time there'll be decimal numbers, and those are your x-intercepts. The reason why that's important, just reviewing roots, is because the next part of your notes, I give you a word problem, which we're going to talk about in a little bit, and I also give you an example question of finding everything about a quadratic. So I'm going to go over, first off, just the example question. And then I'm going to review the word problem on how to find your roots and how to find everything if they're actually giving you a word problem. Okay, so I give you y equals x plus 3 and x minus 1. Now what I'm going to do is this. I'm going to convert this to standard form because this is factored form. I already know when I'm graphing this, I already know if I were to graph it, my a is an invisible 1, so it's going to be curving upward. I know my roots are going to be at -3 and at +1. Now watch, if I convert this to standard form, I'm going to have, what, x squared, -x, 3x is +2x, minus 3. You know, I'm just multiplying this x to both of these, this 3 to both of those terms. And so when I have this now, look, I could actually find my y-intercept, which is 0, -3. Okay. Since I know my shape is 1, I already know my vertex now. I can find it by two ways. I could go from my, actually probably the easiest way would be, let's just keep it simple. Last year, you should have learned this. X equals -b over 2a to find your x coordinate for your vertex. You can use this form when it's in standard form. So you would say -b, which is -2, over 2 times your a, which is 1. So I'm going to get a coordinate of -2 over 2, which is -1. That's my x coordinate from my vertex. How do you find your y coordinate? Plug it back in. Plug the -1 back into here. So if I plug a -1 into x squared, I get +1. If I plug a -1 into 2 times x, I get -2 and then -3. Net 1 minus 2 is -1, and -3 is going to give me -4. That's my vertex. Once again, if I lost you on that, this is totally review, but you might have not done this for a while, so you're using -b over 2a to find your x coordinate. Once you find your x coordinate, you're going to plug it back into, you can plug it into this equation, and you're going to get -4 for your y, because remember, it's always y equals. Or I can plug it into my standard form, and I still get -4. The reason why that's important is because, look, boom, here's -1, -4 is right here, which should make sense to you guys, because my y-intercept was at -3. I know my shape is initially 1. It's an invisible 1, meaning I go up 1 over 1 initially, and that's it. Up 1 over 1 the other way. Now I have 5 points to make a much more accurate graph. Okay, here's my graph. Now I can answer anything. Now looky here. My vertex is already stated. -1, -4. What are my zeros? Well, actually, let's do this. You pause the video right now. With this graph shown, see if you can answer everything that it's asking you to do. So go ahead and pause it and try it right now. Answer vertex, zeros, domain, range, axis of symmetry, all that stuff. Okay, now that you should have paused it and tried it, I'm assuming since this is a STEM class, you guys have got this pretty much. But I'm going to go ahead and answer everything for you. Okay, so my vertex is, I already found that right here, -1, -4. The next question that is asking me is zeros. -3, 0 and 1, 0. Give them to me as roots or zeros or x-intercepts. Do not just give them to me as numbers, because after this course, when you're in Math 4, you're going to be expected to give your roots or solutions or zeros as coordinates. Okay, next thing is domain. The domain is, how far does this graph go left and right, which is the English question. The Mathanese question is, how far, is there any x coordinate that would not be on this graph? The answer is no, because you can plug in any x number here and go all the way up and hit the graph, or any negative x number here and eventually go all the way up and still hit that graph. So my domain is all real numbers, but my range ain't all real numbers, because it doesn't go down forever. My y values are limited from this point right here, which is 1, 2, 3, 4. My range is anything greater than or equal to -4. Just a heads up, your range is always going to be your y number for your vertex. It includes any positive number on my y's. I go up forever because I could go across and hit the graph, but I can't, let's say like at -5. -5 would be here. -5 is not on this graph, so therefore I cannot include it in my range. My range is all the values that pertain to y on the graph. Okay, next thing is the axis of symmetry. Last year, you should have been taught, if you were in my class, you were taught the imaginary line that cuts it in half. That's called the axis of symmetry. This green line, algebraically, is an x line. And just a shortcut, the axis of symmetry is always your x number for your vertex. Remember, my vertex was -1, -4. This graph right here, this line is at -1. That's your axis of symmetry. Your axis of symmetry is also abbreviated as AOS. That's exactly what it's abbreviated as. Y-intercept is 0, -3. Vertex form. Okay. Vertex form is very, very simple. You already found your vertex, which was -1, -4. Your shape was up 1 over 1 initially. Now you have all the information. If we didn't know our shape was up 1 over 1, if we didn't know that because we weren't given any equations, we would plug a coordinate in for the x and the y to solve for your a. However, since we already know everything, it'd be y equals 1 times x minus whatever your x number is, squared, plus whatever your y number is. So it's a -4, and I'm going to clean this up. So if you were to graph this on your graphing calculator, this would be your graph. This is called vertex form. I think the book calls it graphing form. Same thing. What's your minimum or maximum value? For the next thing is minimum or maximum value. Well, this has a minimum value. I don't know my maximum value. It's always referring to your y. What's your highest or lowest y on the graph? That's what your minimum or maximum value is. This graph goes up forever, so this includes infinitely y. However, it limits the y on the bottom. I don't know my highest number, but I know my smallest number on my y, which is your y coordinate for your vertex. So I would say this has a minimum value at what? 1, 2, 3, 4. At -4. That means the smallest value is at -4 on the y. I don't know my largest value because it doesn't have a maximum. And then standard form. I already wrote standard form in the very beginning. I think it was x squared plus 2x minus 3. So x squared plus 2x minus 3. That was your standard form because you just multiply that out. Okay. Okay, the last question that I'm going to talk about is, it says the height. The height h in, I'm going to read this along with you guys. The height h in feet of an object above the ground is given by h equals negative 16 squared plus 64t plus 190. Okay, see how that shape is a negative? It's a negative. That means this graph, I don't know what it's going to look like, but I'm assuming it's going to be looking, I don't know, something like this. It's a shape where it goes off the ground. Think of like kicking a ball. It goes up, 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 up. It reaches maximum height right here. And then symmetrically goes back down the same distance. So let's say it took 2 seconds to get to its maximum height. That would mean it would take another 2 seconds to drop, which would be 4 seconds. So let's say it reached its maximum height at, let's say, 78 feet. It was the highest point. The question is going to be, if you, let's say, it wants you to write the equation of this quadratic. Okay, well, if I'm writing this equation of the quadratic in graphing form, it gives it to you in standard form. But for this, let's say we had to write it in graphing form without any information, without any equations. What we know for sure is that we could say my vertex is positive 2 and 78, which is x minus 2 squared plus 78. Is this the equation of this quadratic? The answer is almost. It's almost the equation. We don't know the exact equation because we need to find our a. Our a is what's missing. So how would you find your a? You plug a coordinate that this graph goes through. Other than your vertex, you can't use your vertex. But you know, let's say this graph, I don't know where it starts. Well, let's say it starts off at 0, 0, meaning you kick it on the ground. I can either use this to plug into my x and to my y to solve for my a, or I can use a coordinate of 4, 0 to plug into my x and plug into my y. I would use 0, 0 to plug into here. So if I were to use 0, 0, it would be 0, which is my y, equals a times 0 minus 2. I'm going to do this a little faster. 0, because you're in STEM, so you can follow along. 0 plugged this into here. Negative 2 squared is 4 plus 78. So cleaning this up, subtract 78 to move this over, and I would have negative 78 equals 4a. And before I reduce it, I would have a shape of negative 4 over 78, which would be what? Whatever. You would just simplify, divide both sides by 4, top and bottom by 4. Anyways, or just change this to a decimal. That's fine too. I don't care. But this should make sense because my shape is a negative, which the graph is a negative. That means it's going down. This is the equation. All right, now what I want you guys to do is pause this video. And see if you can write that in graphing form and answer the question. See how it says t is greater than or equal to 0? That means the second the second the object goes in the air, time has started. You can't have time in a negative. It makes no sense. It has to be in positive. So pause this video and see if you guys can answer that question. All right, since you unpaused it, you should have the answer to that question. All right, so let's see. I'm going to go through, and you should have been able to see that the vertex, if you were to do x equals negative b, which is 64, over 2 times your a, which is negative 16, it would spit you out an answer of positive 2. That's your x coordinate. How do you find your y coordinate? Which is your hx equals, what's the equation? Negative 16 times, plug this 2 in. 2 squared plus 64 times, plug the 2 in, plus 190. This answer is going to give you a height of 254, which is your y. So your vertex is 254. Okay. What that means is, this is my vertex. I'm going to explain what that means, because you're going to have a couple word problems where it's going to ask you questions about stuff in vertex form or graphing form. If I were to write this in graphing form, I don't know my shape, but I'm going to assume my shape's going to be a negative number. But what I do know is x minus 2 squared plus 254. That's not my y-intercept. That means this. You kick, a ball goes in the air. 1 second, 2 seconds. 1, 2. It's at its highest peak of 254 feet. Then it's going to take another 2 seconds to come down. Okay, so I don't know my A, but what I can do is this. I can plug in 0, 0 or 4, 0 into here. And anyways, when I do that, I'm not going to bore you guys with all the math. What do I have? The answer is, oh, it's not even asking for the A. Find the time it takes the object to strike the ground and find the maximum height. Oh, okay, you already did. That's it. The maximum height is 254 feet, which is your y. How long before it takes to hit the ground? Well, if it takes 2 seconds to get up to the height, a ball just doesn't do this, go up 2 seconds and it drops straight down in the air. It's symmetrical. So however many seconds it takes to get to the highest point, it's going to take those exact same amount of time to get back down to the ground. So if it took 2 seconds to reach its highest point, which is 254 feet, it's going to take another 2 seconds to hit the ground. So it's going to hit the ground at 4 seconds. And at the very bottom of your notes, you guys have your next assignment. This next assignment is going to be from Chapter 2. We are not doing any more questions in Chapter 1. This is from Chapter 2. So in your book, it's going to say 2 dash whatever the questions were that I gave you. Do not do from Chapter 1. This is from Chapter 2 for this assignment.